Hello, my SPC friends, and we get to start a new chapter. I hope Chapter 11 test went well. I know you're going to feel like you didn't do well. It always happens. Every student feels like they got it all confused, and it seems like every time it's not as bad as you thought. Okay, so hey, this is our last chapter. We can do this. Section 12.1, we are going to skip that. It's basically just talking about sampling and sample sizes and how you do a survey. And I mean, it's good for a stats class, but this isn't a stats class. This is a liberal arts class. And just for scheduling sake, we're going to just go right to 12.2. Okay? So from the syllabus, just ignore 12.1 and pick it up at 12.2. That's where the homework for 12.2 will be due next week. Okay? All right. So what are we doing in 12.2? Well, we're going to imagine that we've already collected our data. We already were careful in structuring our survey or our analysis and getting our sample sizes correct and eliminating bias and prejudice from our questions. We went through all that. And now we're going to talk about, well, now that we have all this data, how are we going to organize it? How are we going to display it so people can understand what it is we found so that we can communicate the information behind our data? Okay? All right, so one way to do that is through frequency distributions. When you see the word frequency, just think of how many. Okay, frequency, how many. So basically, the idea is to organize our raw data in a meaningful way. Obviously, as the researcher, we would be familiar with it. It's meaningful to us, but so that everybody else can understand what it is that we found, we have to communicate it in meaningful ways. And we're going to go over 3 methods to do that: frequency distributions, stem and leaf plots, and histograms. There are many different others, circle graphs, bar graphs, all kinds of options, but we're just going to go over these 3, okay? So let's go over a categorical frequency distribution first. So here's the idea. Now this is just a small sample. 25 volunteers were given a blood test, and below is the data. The more data you have, the more important it is to organize it and display it in meaningful ways. But even this, it's kind of hard to get a feel for what it is exactly we have. So a frequency distribution will simply make a count, like a tally mark of the different blood types, and quickly see which one's the most, which one's the least, things like that. So basically you just set up the blood type. You've got A, B, AO, and AB, and you just simply draw tally marks. Maybe you have and another researcher, they just start calling it out, and you just mark it as you go. And you actually do the sideways, the diagonal bar for the 5. That is actually a good way to count by 5s, believe it or not. And now you can see, once you get it organized like this, you can see, oh, it looks like blood type O was the most, right? And blood type AB was the least. So information starts to become apparent once you get it organized, okay? So that's a frequency distribution. Another common distribution is a grouped frequency distribution. Maybe you're not interested in individual data as much as groups of data. For example, grades, right? Grades, ages, weights, etc. Maybe you're doing some research on the weights of high school football players. Are they getting bigger, stronger? Are they hitting harder? Maybe that's why we're more concerned about concussions, all sorts of information. But you don't really care about the kid that weighs 187. Maybe you care about the number of students, number of football players that weigh in the 180s or the 190s or the 200s, 210s, things like that. All right, it would be a good time to do a grouped frequency distribution. Now, trust me, this is not an exact science, okay? There's a little bit of a give and take, and as the researcher, you have some flexibility to do things the way you want. It's your research. But here's the idea, okay? Typically, you want the number of classes to be between 5 and 15. You don't want to have 2 classes. That'd be silly. You don't want to have 37 classes. You'll have like 1 or 2 people in each class, and that's almost pointless, okay? So the classes cannot overlap. right? Can't overlap, otherwise you wouldn't know which group to put the data in, right, if it overlapped. We'll talk about that more. Make sure you don't leave out any numbers, and you cover between the lowest and the highest. Even if nothing's in that class, you still have to have a group for it if that's how the data falls. I'll show you. And number 4 is important. The range of the numbers is going to be the same for each class, whatever it is you decide on. Okay? All right, let me show you how this works. So here we got, kind of interesting, the high temperatures for each of the 50 states constructed in we want to do a grouped frequency distribution because we really don't care about 133, 132, 131. Maybe we want to know about the 130s or the 120s or the 110s. So it makes sense to do a grouped frequency distribution here. Okay? And it's kind of hard to see the data in this form. It's all spread out. I can't tell highest, lowest, where were most of the high temperatures, things like that. Okay? So let's take a look at what we got. Step number 1, subtract the highest from the lowest value. So now we can see that we have 34 degrees span the highest and lowest temperature. Okay? And this is where you start to play around a little bit. You say, well, if we used a range of 5 degrees, 5 goes into 34 almost 7 times. And remember, we want between 5 and 15 groups. So 7, that's pretty good. Okay? You could do more or less, and a lot of times what you'll do is you do this in Excel anyways, and you take a look at it and you go, I think I should do a range of 6 degrees or 4 degrees. Okay? Again, if you have the ranges too small, okay, then you'll have too many groups. If your range is too big, you'll have too few groups. So it's kind of a visual thing, and you'll see when we're done. Okay? Let's see. Okay, so we start with the lowest value, which is 100. Okay? And now think about it. We want to add 5 to that to figure out where the top of that first class is. Why 5? Well, because we decided we're going to do a range of 5 degrees. Okay? Now what's interesting is if you add 5, you got to count the 100 as you go. So start at 100 and count 5. 100, 101, 2, 3, 4. Oh, you actually land on 104. Okay? Not 105 because you got to count the 100. So it's 100 to 104 is including 5 different temperatures, 100 to 104. That's the first group. Okay? So remember, you can't have an overlap, so you can't go 100 to 105 and then do the next one starting at 105. That's why it makes more sense to get the bottom of each group figured out first. 100 plus 5 is 105, and then 110, 115, all the way up to 130. So you got your lowest and your highest base number, lowest number in each group. Okay? And now we'll go and build the groups. Now remember, they can't overlap. So once you have the lower numbers figured out, it's actually pretty easy. Because you can only go up to 104, because you can't have 105, because then they'll overlap. So 100 to 104, and 105 to 109, and so on and so on. You're always one less, so that you know exactly where each temperature falls within what group. Okay? So I hope that makes sense. The biggest thing is don't overlap. Don't overlap, and then you should be fine. Each number should only show up one time in your classes or your groups. Classes, groups, same thing. Now you go and do your tally marks, and again, probably you and a researcher friend would call them out, and you just put them in each, so 112. All right, 112 goes in there, cross it out. 100, well, 100 goes in there, cross it out. 127 falls in here, cross it out, and so on and so on. Okay? Go through, and you want to cross them out because you want to make sure you use each one, you don't leave any out, and you don't count them twice. Okay? And there you go. And now you can see that the most common group, or the highest number group for the record high temperatures in the 50 states is right in here. That was the most. There was only one state that hit, what was it? I think it was 134, yeah. Probably Arizona, you think? And down here, the record high was 100 to 104. Probably some state maybe up, maybe Alaska. No, not Alaska. I don't know. Probably some far north state. Maybe up along Alberta or up in there somewheres. One of our states that borders up there. Okay, you get the idea. I'm sorry for rambling. Okay, next one is a histogram. Histogram. Histogram is a graph with observed values on the horizontal scale. So the horizontal is your frequency. Okay, horizontal is the frequency scale. I'm sorry. The observed values on the horizontal, the frequencies are always on the vertical. Frequencies are always on the vertical scale. So if you're looking at how many, that's always going to be the y-axis, the vertical scale. Okay? You'll see these a lot in magazines, USA Today, along with pie charts and things like that. People can figure out information really quick just by looking at it. It has a good visual quality to it. Okay? So here's how we construct them. Bar graph is constructed above each observed value, and I'll show you what an observed value is here in a second. I think we're going to use the same data that we had, or we're going to start something new here. And you can also have a class. It could be a specific value. In other words, how many people have an IQ of 107. That could be an observed value, or the observed value could be how many people are in the IQ scale, IQ group from 100 to 110, 105 to 115, something like that. It could be a class. Okay? The horizontal scale doesn't need to start at 0. The calibrations on the horizontal and vertical scale do not have to be the same, but they need to be consistent on each scale. Not with each other, but on each scale. And I'll show you that. The vertical scale must start at 0. Okay? Now, if your data, for example, maybe you're doing weights of college football players, and they're probably going to start in the 170s, 180s. So you're going to kind of crunch the y-axis down. And instead of it looking like this, you'll see it look like this. And then maybe they'll start at 170. Meaning they took a big jump, or they just crunched the y-axis down, and they have to communicate that. So that you don't think they were trying to trick you. Okay, that's pretty common to see that break in the graph. Okay, right there. All right. Now what we're going to do, I'm going to pause this because I'm trying to keep the videos right around 10-12 minutes so that they're not too hard to upload and download. So you'll just be looking for video number 2 for 12.2, and this will continue the lecture. And you actually only got about 8 more slides left, but we're going to stop it now, and we'll pick it up here in a minute. I just have to switch over to another video. Okay, see you in a minute.